Good afternoon, Year 4, and here is your science lesson for Tuesday, the 2nd of February. This is lesson 5 of our sound unit, and today we will be learning to set up a simple practical inquiry to explain how sound travels. So this is the first part of 2 lessons. You'll do the setup today, and then you'll carry out your investigation next week. But your steps to success today, you're going to be setting it up, and you will today be making a prediction. You'll identify variables and you will organize your equipment. Okay, let's get started then. So what does it mean to set up a simple practical inquiry? What will you need to include? Have a think about that just for a moment. Okay, and then have a think about where you are in your learning pit today. Will you find it challenging to make predictions, to set things up? Will you find that easy? Do you just want to get started and not do any of the science beforehand? But what will help us succeed today? Okay, so we're going to start straight away with our Emmet problem today. And Emmet says, I think that the further you are from a sound source, the quieter it will be. Emmet thinks that the distance affects the sound and that sound will be quieter if you're further away. Do you agree or disagree with Emmet, and why? So think about the knowledge that we've learned over the last few lessons on sound, especially last lesson where we were looking at distance. Do you agree or disagree with Emmet, and why? It's important that you have some kind of reasoning or some kind of explanation as to why you think that at the moment, but don't worry because it might change in a minute. Okay. So he then says again, I think that the further you are from the source of the sound, the quieter it will be. How could we therefore investigate this statement? What kind of things would you need? And what variables would need to stay the same or change? And just remember that word variables are the things that you change in the experiment or the things that need to keep it the same for it to be a fair test. Pause the video here if you can and just have a think about those questions before we move on. Okay. So sound over distance. If I was in school with you, I would be trying this with you. So I'm going to ask you to imagine it for now, or ask a parent or Mrs. Chamberlain maybe to get involved. So it says for the teacher to play an instrument or create a noise of some kind on the playground, and then the class will listen to the sound. So you've got to make sure that you hear it first of all. And then every time Mrs. Chamberlain bangs it, or your parent does, or you're outside in your space, to move one step away and to listen to the sound again, and to continue moving away one step each time, but stop and listen to how loud it is. What do you think will happen? If you're closer to the sound and then you move a step away, a step away, a step away, a step away, what do you think is going to happen to the sound at this point? Okay. So we know that vibrations spread out and get smaller as they travel, making sounds quieter as we move further away from the source. But often people need to be able to hear sounds from far away. Can you think of any devices that transmit sound over distance, or ways of making sounds louder so they can travel further? Think about needing to have to say something to someone if you are in the classroom and your friend is out on the other side of the astro. Think about that kind of distance and how would you make sure that they could hear you? What could you do? Again, pause the video here if you need to before I reveal some of the answers that are hidden at the moment. Okay, so if you need to get something that kind of distance away, maybe even further, some of these things will help you. A phone, how does that transmit sound from where you're phoning someone to the other side of the astro? Maybe a radio, where are the people broadcasting the radio from and how does everyone get to hear it? Maybe putting your hands around your mouth and really shouting. Why does that help? A television, when things are recorded for TV and films and things, and we still get to hear the sound now. How does that happen? Maybe a microphone and a speaker system, and finally a walkie-talkie. Okay, so there are ways around the distance. Telephone, let's start with that then. So telephones are used to transmit the sounds of people's voices over those long distances. When you speak into a telephone, the sound energy in your voice is turned into electrical energy, and that is transported down a wire to the other person's telephone. The electrical energy is converted back into sound energy, and they can hear what you're saying. Simple-ish process in theory, but it's quite tricky to actually understand that. So when it goes through your phone, it turns into the energy and it goes all around the wires and then it comes back and it's transmitted back into sound for the other person to hear. Our investigation then. So this is what we're going to be doing next week, but you are planning it today. So it says your challenge over the next 2 lessons is to create a string telephone that will transmit the sound of your voice over a distance. So you can see 2 children stood here, 1 girl and 1 boy, it doesn't matter, just 2 children for now, and without a string telephone. And you can see this girl here is trying to say something to the boy. You can then see in the second diagram that they are still exactly the same distance apart, but this time they have a string telephone. So have a think about what you'll need to test and what variables will need to stay the same or which ones you'll change. So I did give you a couple of clues as I was explaining that. Pause the video here if you need to, have a think about what that might look like and what might happen, and then we'll start planning. Okay, so like I've said, your task today is going to be to plan your simple practical inquiry. So please complete your question, prediction, and variables section of your planning. To complete Go Deep, you must include detail in your answers and reasons why. So that's your Do It and Go Deep together. So over here on the right-hand side, on your page, I have the Emmet question for you, and that can just be stuck in at the top, or I have included it on the page on your sheet today. So Emmet thinks that the further you are from the sound, the quieter it will be. So what is our question? What are we trying to find out with our string telephone or without our string telephone? What kind of question can you come up with? And again, they don't have to be exactly the same as everyone else's, but what is your question? What I'm going to ask you to do is to then write that on your question line. And then I'm going to ask you to make your prediction. So it says here, prediction, describe what you think will happen and why. And remember, to achieve Go Deep, you need to explain that why. So you might say, I predict that my partner, so the other person of those 2, will be able to hear me exactly the same whether we have this string instrument or not. Or you might say, I think they will hear me less because the cup for the string telephone will get in the way, or I think they will hear me better. Always with that because on the end. Please, please, please explain why. Then finally, your variables section. What will you change, measure, and keep the same during your investigation? So remember, your variables, your independent variables, this first box, what do you need to change? So what are we doing first of all? What will we be doing second of all? That's one of the things we're changing. The dependent variable, what will you measure, observe? Maybe it's going to be how loud the sound is. Maybe it's going to be how clear it is, how far away you might be potentially. And then your control variable. To keep it a fair test almost, what do you need to keep the same? Would it be fair if you were testing it from one side of the playground to the other, and then one person stood all the way on the astro, for example? That kind of leads into your Go Deeper then. So finally at the bottom, I'd like you to just write Go Deeper, and your Go Deeper task is to explain how you'll carry out a fair test. What equipment or features are you going to keep the same, and how many times are you going to do the test? Is it good enough to just do it once? Is it okay to have 2 different sets of string telephones, for example? So you can write your Go Deeper answer just in a line or 2 after that. Good luck with your planning today. I know that you're really going to enjoy the experiment next week, but the whole point of going through the process of the planning, the question prediction variables, really important for your science skills. I'm going to let you pause the video and have a go at this now, but just come back at the end for the working scientifically and the learning pit. See you in a minute. Okay, well done at having a go at that. I can't wait to see some of your planning and to see how some of you will have interpreted it differently. And like I said, it's absolutely fine to do it slightly differently because this is your science experiment and it's the results that you're going to come back with. Just have a think about here then, there is one or two probably key ones today that we have focused on. Hopefully you'll spot them because they are included in our WALT. So you can have a look at which working scientifically skill we focused on. And then just have a think about today. How did you find setting up or planning your inquiry? Where are you on the learning pit? And again, just think about, if you can, what helped you to succeed today if you are out of the learning pit, or what challenges you might have faced down here and how you can then progress out of it next time. A huge well done from me for today, and I really look forward to the lesson next week where you will be having a go at this experiment. See you soon. Bye for now.